Okay, this is Miss Webb. I've done this video at least 6 times. If I make a mistake, I'm going to keep going. Okay, our objective in lesson 6 is that we're going to calculate the probability using the complement rule, which we've informally used in lessons actually 4 and 5. And we're going to give you a formula for that conditional probability, which is really nice instead of having to do a lot of work. And we're going to talk about the multiplication rule for independent events, and I'm pretty sure you have definitely seen that in Algebra 1. Okay, so I skipped over when they talked about the complement rule because we've done it before in the previous lessons. Okay, if you have the probability of not A, it's going to be 1 minus the probability that A happens, because we know it's 100%. Okay, example, if you have the probability the particular flight is on time is 0.78, the probability of it not being on time is going to be equal to 1 minus the probability of it being on time. It's going to be 0.22 or 22%. Okay, and we've used that before in other lessons. Okay, we're going to talk about the formula for conditional probability. So let's read the example. You've got a room that's in a downtown hotel. They're going to tell you A is the room has a king-size bed. B is the room has a view. Okay, and they're going to give us some information about it. And the first question they ask is, what is the meaning of probability of A given B? Well, that's the probability that given you have a room with a view, what's the probability of it having a king-size bed? So what we're going to do this time is we're going to do one of those hypothetical 1,000 tables to figure out what the probability of A given B is. So if you remember correctly on those, we fill out this for sure. Okay, we picked 1,000, so it's easy to put the numbers in, or we could actually, if we're going to do probability, but now let's leave it as 1,000. That's easy. Okay, they tell me the probability the room has a king-size bed is 0.62. Room has a king-size bed. 620 of them must have a king-size bed because that's 62% of 1,000. The probability the room has a view of the town square. So here's a view of the town square is 430 or 43%. And the probability that it has a king-size bed and a view is 0.38. Okay, I'm going to fill out the rest of the table. Okay, I'm going to get my calculator out so I don't make any mistakes. Okay, so let's see. 1,000 minus 430, I know this one's 570. 620 minus 380, that's got to be 240. Now I'm going to go this way along the rows. 430 minus 380 would have to be 50. 570 minus 240 would give me 330. If I add those up, I got 380. So using this table, what do I know about the probability of A given B? Well, the probability that it has a king-size bed, given that the room has a view of the town square, is 380, and it's going to be divided by 430. We got 0.884. But you know, I really don't want to have to do a two-way table every time. It'd be kind of nice if I had a formula for this, and I wouldn't have to do a two-way table each time. And that's what they're going to show you. The formula for a conditional probability is if you have the probability of A given B, you take the probability of A and B and divide it by the probability of B. And they gave us this. They told us the probability of A and B is what? 0.38. Divided by the probability of B that it has a view. I put that in my calculator, and guess what? I get the exact same thing. So this formula is pretty nice. Okay, they're exactly the same, but one takes a little less time, and I get 0.884. So I really like that formula. Okay, so let's do one more. Okay, this one we're going to talk about, we're going to use that conditional probability formula. Let's see if we can get pretty good at it. If I want to know, I'm going to find out the probability of L, probability of F, and the probability of L and F. Okay, a credit card company states that 42% of its customers are classified as long-term cardholders. They're going to do that as an L. A probability of L is equal to 0.42. And let me get my other notes out. Okay, and the probability of F is that they pay their bill in full every single time, which Mrs. Webb has harped on you guys, you always want to do. They tell you that that is 35%. So probability is 0.35. Okay, the probability of L and F, they tell that to you, and it's 0.23. Okay? Now they want you to draw a Venn diagram and label it with the probabilities from part A. Can you do that? I think you can do that. I would have probability of L, probability L, F. Remember, one's going to come down here, one's going to come down here, and that 0.23 is going to go in the middle. Let's do a nice pretty picture. There, I did it for you. 0.23 is here. That 0.42, remember it comes out here and it's the whole circle. Okay? Now use the conditional probability formula to calculate the probability of L given F. Well, what's the probability of L and F? It's this one right here, that both of them are true. And what's the probability of F? Let's see. Can't see very well. 3.5. And what do we get? Let me see. Let me get my calculator out. And what am I getting? I'm getting 0.657. Okay. Now, let's do the probability of F given L. And we're going to use the formula. And I left the Venn diagram down here. The probability of F and L we knew was 0.23. And the probability of L was 0.42. That is equal to 0.548. So F given L is 0.548. Probability of just F is 0.35, according to my Venn. Notice this guy's a lot higher. Okay, and what does that mean? Okay, it means that the long-term credit card holders, long-term guys, have a higher probability, or we could say are more likely to pay their bill in full than just a general customer. Does that make sense to you? Okay. Now, do you remember the two events A and B are said to be independent if the probability of A given B is equal to the probability of A? That means they're independent. It doesn't matter if you did something else. The probability is exactly the same. Now, are the events F and L independent? Well, we know that's not true from up here, but I went ahead and wrote them out for you. I know that's not, no, because the probability of F given L does not equal the probability of F. L given F doesn't work. And the probability of L and F does not equal the probability of L times the probability And that's what we did before on another lesson. But it's kind of, this part down here is a really important one. Okay, because that's going to give us a new, you can think of a new rule. If you want to know the probability of L and F, it's the probability of L times the probability of F. And you know now that they are independent. These two guys are independent if and only if probability of L and F equal the probability of L times the probability of F. That might be a little bit easier to use than some of these up here, depending on what information you're given. Okay, let's look at this. They do kind of a little proof for you. It says if the events A and B are independent, then we know that the probability of A given B is equal to the probability of A. That's that conditional one that we were taught in a previous lesson. Okay, then we have this new conditional probability. The new conditional probability says, well, I know the conditional probability A given B is equal to probability of A and B divided by the probability of B. So what they're going to do now is they're just going to do some replacement here. We're going to bring this down, and we're going to go replace this right here. Okay, so they brought that one down. They took this and they replaced it with this one right here. And then they cross-multiplied, or you could think they isolated the probability of A and B by multiplying times probability B on both sides. And look what we find. We find if you have two independent events, then the probability of A and B, you can multiply them. And that's how we get our multiplication rule for independent events. Okay, so if you have two independent events, you could just multiply the probability of A times the probability of B. Okay, now I'm going to stop the video and we're going to use that multiplication rule for independent events in the next few examples.